Hello, my name is Roger Schroeder. I'm going to be the instructor for this course, Computer Visualization. I'll be the lead instructor taking care of the lectures, and if you have me in a given section, you may also have me for lab. Um, so let's get started. I'll tell you a little bit about myself. We'll go through a general course outline, how to use Blackboard, and then we'll discuss some of the projects that we're going to do. Actually, we'll discuss all of the projects that we're going to do. So let me just get rid of my face here a minute and go to full screen. In general, about myself, I'm a designer, not an architect. I started out doing product design, exercise equipment, medical equipment, children's products, and I got involved at UB as a research professor doing product development work for disabled people. And that was in the School of Architecture. That really kind of fired me up about architecture. And I consulted then after that for a couple of companies locally that are, at least world U.S. renowned architectural product providers, Boston Valley Terracotta and Rigidized Metals. But one of the things that brings me to teaching and one of my biggest interests is the idea of the powerful tools that we have at our disposal to do digital modeling. And that's especially why I like teaching this class. So to get started, I'd like to find out a little bit about you. So there's a survey here that you can take that will allow you to, feed me some information about where you're starting from. It just takes a minute. It's only about 6 questions. Take a few minutes to do that. And then if we're in person and this is not a videotape, we'll discuss it in class. Otherwise, if it's being done online, I can take a look at the surveys and we can discuss it offline. So why don't we flip over to Blackboard and I'll talk a little bit about the layout of this, the content for the class. So I'm going to escape out of this and we'll go over to the actual Blackboard page, which you'll have available to you. I kind of wanted to talk a little bit about the way I lay out the pages and the content to make it a little easier for you to navigate. Let's start out with the syllabus, and I'll just read it to you. This is an introductory course that examines the practical and theoretical issues of the computer as a tool for design and production of architectural concepts, presentations, and construction documents. Technical skills in CAD are learned through tutorials and projects, which are the modules that we're going to do. And students learn to create and execute digital projects utilizing various aspects of this model-centric environment. That means we build one model and then we can cut it apart and visualize it and share it in many different ways, which is one of the powers of BIM. And we'll get started into looking at that in the very first modules that we'll do. We have goals that objectives of learning. And I think, in the broader picture, it is to prepare you for studio work and then later on for professional work. To construct architectural computer models, that'll be primarily what we do. We'll be using lighting and texture, obviously, to embellish our models and to glean information because we can use lighting to understand the effects of solar gain and heat on buildings. We're going to present computer-created projects through printed and electronic media. That means we're going to learn to take what we've done in the software and bring it out to the real world. We're going to create three-dimensional commercial building details, which is kind of back to that idea of how we can cut up a model and examine it, kind of dissect it. And we're going to create two-dimensional building plans and details. And if you're not familiar with the practice of architecture, this idea of these two-dimensional building plans are the historical way that we communicate with the builders to elaborate on how we want something constructed. So you may already know it's separated on Tuesdays, our lecture day. On Wednesday or Thursday will be our lab day. We expect you to have a laptop for you. That's a requirement of the program. You can obviously get by without one for the very initial parts of a course like this because we have a computer lab. But in the long run, the idea of having your own personal machines is significantly important to your success. In this class, we're going to use basically, we'll use possibly a couple of other pieces of software like Photoshop and Illustrator. I'm not sure if you're familiar with those, but we'll get into that. But our primary tool is Revit, and that software can be downloaded either on the Alfred State server, or you can go to autodesk.com. This is hyperlinked, and this will take you to the educational place. And I notice now that I say here it's free to use software for 3 years, but as I looked at the site just the other day, they think they're only allowing the license for 1 year, which means you need to renew it yearly. So I'm not exactly sure how that policy is panning out currently. We're going to go through the module outline kind of in detail, so I won't bother you with that. And we'll talk about this in the slides, the idea of this naming convention for our projects. And that's for what's called accreditation. We need to show the work that's done to people who certify our program. And so this naming convention helps us with filing and recording and archiving the projects that we do in classes. You're not expected to do any printing in this course, so that's one expense that you might be able to save and spend on studio work that you're doing. And there's also no textbook required. Typically, I grade basically on the projects that we do. We'll have one check drawing and maybe a final project, but I typically work every project on a basis of 10 points. 10 being you've done everything that I've asked of you. We're going to discuss a little more in detail this idea of a narrative describing the project's experience. But once you've made your project sheet up and done it well, I'm asking you also to write a little bit about it. All of that counts towards points, and it also gives me information on how well we're communicating and learning between us. It's a little bit about listening to what your feelings are on the projects we do. You're expected to be in lecture all the time. I run this course as an online course too, but this school is really focused on in-person experiences, so I expect and require you to be in lecture unless you have an excused absence. And it goes without saying, academic integrity is paramount. In this course, it is easy to take shortcuts or to try to copy, and there's absolutely no need for it, and I'm really good at catching it. So save yourself a lot of heartache. Last semester, I actually had to flunk a student because he submitted other people's work, and that was really heart-wrenching and very expensive for the student. Time management, this is in here, but I respect your time a great deal. I realize that your programs can put a lot of demands on you, so I try to make all of the work that's required for this course to happen inside of this course environment. And these are just other statements about your privacy rights. Special needs, obviously, if there is any disability or you have any reason that makes it difficult for you to do the task in the classroom, you can reach out. We have a really effective program to helping anyone with any kind of disabilities. If you have an undocumented disability or something you didn't want to share with other people and you think I can help make accommodations, please feel free to reach out to me. I'm more than willing to work with students to see your success. And a pressing concern today is this idea about equity and diversity. So the university takes it seriously, and I'd like to reiterate that I take it very seriously. To recognize each individual, regardless of race, origins, sexual orientations, or anything else. We're all treated equal within this classroom, and of course we expect that treatment to be reciprocated by our fellow students. So that covers the syllabus. Let us go back to the slideshow now for a moment, and as soon as I can find it here. I want to talk about this naming convention, mostly because if we get it out of the way and you get it done with, you won't be doing this later on. Every time you're going to turn in a project weekly in this course, so getting this naming convention down will really facilitate saving you time. So the idea is that each file that you submit should be labeled A is for ARCH 2014, which is the course, your last name, your first name, or hold on, let me see here what it says. the first letter of your first name, and then the project, which is M1 or M2. And then sometimes we have 2 images or 3 images that we might have to submit. And so it's a -1, a -2, and so on. So, and then even if you don't do these and you submit them, in the end, you can go back and rename these. So it's not absolutely critical that you do it from the start. It just will save you a whole host of time to get into this habit. So I recommend you do it from the beginning. Okay, a little bit about the kind of like the timeline, the structure, how much we're going to cover. I've laid out the schedule here. And I want to mention too that, and maybe I should do this right away, that because you might be looking for recording this resource. So I'm gonna click Escape and go back to the syllabus, and I want to show you that in M4 I have the discussion slides that I'm showing you. They're hyperlinked. So on every section that we have a lecture, and then we have the project down here, I also create a hyperlink that takes you to those Google Slides. So if I was to click on this, and right now the link is wrong because I'm one ahead, I haven't corrected that on the site yet, it'll take you to that slideshow. And then anything that's hyperlinked within this, which means that if you click on something and it's got a hyperlink, let me see if I can find something with a hyperlink. I don't think there is one in this slideshow. It will take you to that exact location. So anytime you see something on the screen and I mention that there's a link to it, open up the slideshow and you can click on that link to get to it. And that'll happen with all of the discussion slides. And I may have the lectures in videotape, sometimes I may not, depending on whether I have actually gotten to them or not. And I try every year to redo these, and so they're always a little bit different. Okay, so back to our slideshow presentation. And let me go full screen here. Oops. Okay, so if you're watching this lecture or we're talking about it, this is our January 26th lecture, and it's online. So we'll be delivering this through Collaborate. And then when we start our online classes, or excuse me, our in-person classes, we're going to go through February, March, and all of April. So that's 12 weeks right there. Actually 14. So we'll have in total with the online and part of May, we'll have 15 weeks. And of that, I've tried to pack up all of the content into modules so that we can keep things relatively well organized. And each week that you accomplish a goal, many times it leads into the next goal of the next week. So I've tried to create as much continuity between the modules. But we have our lecture, and I try to prepare you for what we're going to do in our lab by discussing some of those issues in lecture, and sometimes I try to add other elements inside of lecture. So we'll try to do 50 minutes of lecture, maybe 50 minutes or another 30 minutes of some kind of an active learning exercise, which I've got laid out over here. And then in lab, you'll do the module projects. And we're going to discuss those in detail coming up here. So a little bit about how we work through the lab modules. And they're really the heart of the program. And this year, what I've done is I moved the lecture modules to YouTube. So the videotapes are now, or the video is now organized according to YouTube. You can actually click in, if we go to Black, I'll show you when we get back to Blackboard, that you can actually click right through and view them in YouTube. And the nice thing about the YouTube presentation is it has a couple of nice features. One is it lists the whole playlist for the project, so you can go backwards and forwards as you may need to. And you can adjust, to me, one of the important things is the speed. Actually, let me take a minute and show you what I mean by that. So here I am at Module 1, and I'm going to click this through so it starts playing the video. This is a brief introduction to... And one of the things I could click through is I can go right to full screen, which is nice, right? So there's me talking to me. And YouTube provides a couple of features, and actually let me hide myself here as soon as I can get over to the Me Gone. All right, so let's now go to HD. A couple of things I want to point out. The quality says it's auto 1080. I really want that to make sure that it's 1080, so I'm going to recommend to you that you turn this to 1080 up here and not use it in auto mode. That means it'll always deliver the highest resolution content. That's really important when you're trying to see some details that are on the Revit screen, and that'll become clear as we move into that building environment. Let me see if I can go to a video that demonstrates that. And I'll show you what the playlist looks like. I'm going to click on this. Out comes the playlist. We'll move into another play element. And now if you see the detail within the Revit interface, the software that we're using, is nice and crisp and easy to view. If you're seeing details that are actually of really poor quality, for instance, like that, remember that you need to reset this so that it says 1080p HD. It's the way they were recorded, and that's the way they'll play best. You can also click through, if you're having problems seeing this that way, you can click through to YouTube and go right to that playlist within the YouTube environment. But that's not necessary to do that. So the other thing I try to do, especially this year, is add this idea of the objectives, what our objectives are of each module. This is more for making sure that we cover all of the elements. So like for instance, in M1, we're going to learn how to make walls, elements, roof elements, modify things, and do what's called a sheet layout. And every module will have that kind of idea about what the objectives are. I've already mentioned the 1080p. Okay, something that I think is important is having a really good work environment to work in. And so what I'd like to take a few minutes is to talk about this. Because I based the course on this idea of watching videos and then doing the exact duplicate work or your own version of it on another screen, it's really nice to have a second workplace or a second work screen. Mostly all laptops have the ability to plug in an external display. If you can get access to an external display, it's going to make things a lot easier for you. If you don't have access to an external display, one of the solutions is to use the computer lab and use one of those computers to play the videos and use your laptop or vice versa to actually do the project in. It's really important too that they have good high resolution because there's a lot of details that happen within that interface. So most 19-inch monitors today have what's called 1080p resolution, 1620 pixels by 1080 pixels. Also, many students, not many, but over the years, quite a few students try to work with their laptop not using a mouse because they're not coming from the design drawing kind of environment. And they try to use the trackpad. And I really strongly discourage that. I actually require you to use a mouse because of the way I talk about doing functions. I talk about clicking the left and right button. And many of the functions are just really cumbersome using a trackpad. So do yourself a favor right now, get a mouse, get adjusted to one. If you don't have a mouse, you can ask me and I can probably scrounge one up for you. So keep that in mind. And then kind of on the fun aspect of this idea of layouts, this is my layout in the office that I'm actually presenting this video in right now. This is a little different this year. I now have 2 monitors and I'm not using a laptop. I've got a desktop. But I really have a large 32-inch display with that gives me lots of real estate to draw with. But I'm not suggesting that you need to purchase this or have it, but it really is a very pleasant way to work. I'm really into supporting you in any way I can, which means that I expect you to ask for help when you need it. The idea is that if you're struggling with a project and you can't accomplish something, you can't figure out how to do it, or it's not turning out right, if you've spent 15 minutes and you're very frustrated, reach out to me. Send me an email. Typically what I suggest you do is you include the file itself, the Revit file or the document file that we're working on. Send it to me with some kind of description of what your problem is, and I will try to respond as promptly as I can. If I'm going to be really delayed, I'll email you back. But typically, if I'm at my computer, I can almost respond right away. And my workday typically has me in front of the computer, and I'm even available at night. So, and I say this because very few students ultimately reach out. So please take advantage of it. Don't be frustrated needlessly. If there are some things that you're just not getting, you might just need a little bit of a little pressure to break the logjam, or a little help to break the logjam. So when I came to start teaching this course, I knew nothing about Revit, and that was 5 years ago. And I spent all of my time basically using all of the resources that were around, things like LinkedIn Learning, YouTube, and I suggest that you also can take advantage of those also. This year, in prior years, we used to have a resource called lynda.com, which was an educational resource. I think since then it's been purchased by LinkedIn, and LinkedIn now has a lot of courses that are available to us. And they're available to us because we are an educational facility that has a license with them. So one of the things you may want to do right away, just to find out how much learning is available to you, is to go to linkedin.com if you haven't already and sign in. If you sign in with your, this is actually something to be a little bit concerned about. If you want your LinkedIn name to go forward even after you leave school, I would suggest you use your own personal email. But when you want to sign into LinkedIn Learning, you can sign in with your Alfred State email. And that will take you, I believe, through the one-step sign-in, and that will take you to the LinkedIn Learning resources. It's just a whole host of great learning materials and very well organized. And like I said, that's not your only way to get help. YouTube is an excellent resource. There are many people who spend all of their time generating Revit tutorial content and solutions on it. And so plenty of resources right there. And I'll pick out a couple of them that I've gotten a whole lot of learning out of later on as we go forward. I'm not sure if it's happening this year, but typically there's a structured learning help session. And I'm saying this is actually from last year. It's been set up for the course. So there's extra help available on top of whatever I can do. Basically, I would hope that you don't need to have structured learning because you can keep everything up to date. But if you do, it's there for you. I don't want you to get the impression, though, that this is a hard course. This is really basically, most people think this is a medium course to an easy course in the surveys that have been taken as we've exited the courses. One of the ways we get our information, where I get my grading, is that you submit a final project sheet, and I have a special place that describes how to submit to the blogs, how to format the files and properly submit them. This is probably one of the things that students early on spend the most amount of time trying to get organized, so I try to make it as efficient as possible. So I go through and describe this in our first module, and then I also keep this link available to you so that you can go back and review. Many times the errors are the image isn't showing in the blog because the file's been submitted wrong or because it's not the right size, and these are easily correctable things. So one of the responsibilities that you have right now is to get set up with Revit. So I've shown you in the syllabus there's 2 ways to start with Revit. But I would suggest that it's been my experience to go directly to Autodesk and sign up and download the product. But you can also do it through the university. And one of the resources you have is the help desk here for any problems that you have. Revit is a relatively large file download, and one of the best ways to do that is to do it through an Ethernet connection, which is the wireless cable or the wired cable that goes between the computer and the desktop. And if you are, on the counters that are in the rooms. So if you have any questions about that or need any help with getting Autodesk started, please reach out to me right away. I want us to be able to accomplish a lab this week. If you can't get Autodesk, if you can't get Revit loaded onto your computer, you can't get it running, you still don't have a crisis because we have computer labs available that you can do the projects on. Okay, so let's talk a little bit about just the general overviews of our course. I guess one of my overarching ideas here is that I'm going to teach how to do all of the kind of tasks that you need to do to architecturally communicate with drawings and details. But through a large part of your education in studio work, many times the job is to communicate compelling ideas quickly. Um, I want you to be able to sketch, obviously, but I also want you to be able to work in a computer and digital modeling space and create ideas and versions of ideas quickly and efficiently so that you can have rewarding and effective dialogues with your instructors that can lead to improved outcomes for your projects. So the course format, once again, we'll have a lecture, that's Tuesday. We'll talk about terms and ideas about the upcoming lab. We'll try to do a little bit of active learning, but the predominant part of our active learning is to do the lab section and go through the video learning modules. I show this slide. This is kind of like the historical evolution of our design process. We're still in it. We'll continue to be in it. It's an evolving part or aspect of architecture. Obviously, the first slide is the early days of architectural draftsmen, men, male-dominated, working at drafting tables, hand drawing documents. In the 70s, it still seems like ancient history. Computers began to become available, but the interesting thing about this image is there was the computer expert, and there was the person who was directing that expert to design the things they wanted. And now we live in an age where the person who is using the computer is the expert, is the designer at the same time. And we're moving now into a virtual world, where we can actually really experience our architecture as if we were immersed in it. And that's, we're there now, but we're at the beginnings of it. And that really affords an exciting opportunity about where we're going, how we interact with our models, how we create and work with others when we want to create architecture. A good question you should have is, why are we focusing on Revit? And I have a pedagogy, an idea behind that that I've tried to push forward in this course and through the program itself, that we don't use Revit because it's Revit. We use it because it's a BIM modeler, building information modeler, that is the premier one, the one that is used by most architectural firms. So I'm both trying to use it as a very strong and powerful learning tool, because it gives us so much visual information, but also as one that builds your skill set so that you'll be better positioned for employment later on. And there are surveys that show kind of what kind of digital skills that architectural firms are looking for. So in this highlight here, and I think I have a close-up of it, we have this idea that Revit is 71%. And that this was done a few years ago. I would be willing to say that Revit is a requirement for more than 90% of firms. SketchUp is still considered something important, but you can see where it sits, and Photoshop and a bunch of these other ones. And I'm not discounting the importance of learning these, especially things like a little bit about AutoCAD, but our predominant focus will be inside of this Revit BIM modeling environment. So this is a little hard to describe for people who are just coming into architecture, but we spend, in the academic life, we do projects in a different way than we do in practice. We spend a large part of our process in the academic world going through schematic design ideas and design development. We spend a little time technically going through creating construction documents, but not nearly to the level that architectural firms do, because they need to move these documents off to bid, negotiate, and actual construction phases. So we spend an inordinate amount of time here. but it is actually really only a very small part of what architectural practice is. And that's one of the reasons why we want to learn this software, because this software, BIM software, Building Information Management software, makes this connection between design development and construction documents very seamless. So here's a little visuals of kind of what the idea of these design elements are. So we have schematic design. You're sketching on a paper to indicate how you're solving or dealing or addressing issues on site or with programming. You then move to design development, where you start to create mock-up models, improve, appearance, massing models. And then you move eventually into this idea of construction documents, where you're detailing out how the actual element gets built. So I'm always faced with this idea that I present you with a bunch of projects that I want you to go through and make these buildings. And one of the things I don't want to do is make you feel like these are premier or important kinds of designs. They're really just intended, the projects that we go through are just intended to have the components that you need to learn the software and the techniques of design. So I don't want you to get the impression that if you have a traditional or a modern aesthetic to which you want to aspire to in your architectural career, this course isn't designed to put any kind of intellectual caps on that. It's just that we're limited with the kind of ideas that we can present in an introductory course. Another consideration of the way this course is laid out in modules is that we want to develop habits about learning. So this is something I saw the other day in an article, and I thought it was quite interesting. How long it takes to learn a habit. That idea of a habit to me is a good habit. The idea of how quickly can I decide I'm going to grab a tool, draw a wall, put a window in, change an elevation, do a massing model. How long does it take me to learn those behaviors so that I can do them without having to use reference materials? And so, despite popular lore, it takes an average of 66 days for a new behavior to become a habit. So that really kind of directly aligns with this idea of how long we're going to be practicing things in this course. So now I'm going to take a few minutes and step through all of the modules that we're going to do in this course, kind of just give you an idea about why they're created, why I think they're important. Obviously, M1 is to just get you introduced to a BIM modeling environment. And this is one of the essential ideas about what a BIM modeler is. A BIM modeler allows you to create models, which we're looking to here. In this case, I have you construct one building and then duplicate it over, and we modify and change it as we move along. But we also get, by creating other views, we get these construction documents, or these starts, so to say, start, or what would be construction documents, or other ways of communicating ideas about our models. So we can get what's called a front elevation. In this case, it's a site plan or a floor plan of the buildings as it sits on the site. And then we can render and create presentation materials from the model that we created. So this is our first project. It gets us comfortable with the basic functions of organizing and building elements in an architectural BIM modeler. In our next project, we're actually going to work through this for a bunch of weeks. We're going to start out by making a steel frame, a modular steel frame with which to erect a facade in a building on. We'll go through and create a foundation system, put steel girders in, and then add other elements. So the first part of this module is this idea of laying out a grid system. This helps us determine spatial relationships, understandings about how far a building member might need to be able to span. So we have some ideas about whether we're making feasible structural elements or not. And I don't expect you to understand the ideas of structure. I just want us to get us into this kind of a more rigorous way of thinking about how we form and shape buildings. And it helps us to understand the modeler a little bit better. And also, we get wonderful visual details here about, and when we start in the software spinning the model around and looking at the details of what a foundation looks like, what looks like when steel makes connection with other pieces of steel, these are very reinforcing in the way that they help us understand architecture. Then in the next week of that module, so this will be something that this will be the completed project that you'll submit. The next week we'll go through and we'll put on the facade elements, the floor elements. We'll look at slicing our model, adding a mezzanine element, just the various ways that we can actually construct components in buildings. Once we have our building constructed, we'll start to look at ways that we can actually use that model, the model that we've created now, to create presentation materials. So in this week, we look at using the same model, but just doing different rendering techniques. This allows us to communicate to our client, maybe that we're in the early stages by using a sketchy look, or we're in later stages by using this fine look. But these are all coming out of our software that we're using. The idea is that we can make full presentation documents without having to go out to other software. And then along with that, we go in and look at creating the construction details, the layouts for the foundations, the walls. We'll section through the building, we'll zoom in and look at the details of it, and we'll get a familiarity with how we can cut a model up in order to communicate what we need to do to the people who are going to build it for us. And then we go through and start to embellish and add architectural details. We'll build, in the next module, we'll build an awning, we'll put some signage up. We'll work through putting a stairway in and starting with railing systems. We'll develop site context. We'll build a nicer looking curb system and a sidewalk. So we'll have all of the tools that we need, that you'll need, excuse me, when you start to move off to doing studio projects. We'll start to look at adding textures and different materials to our buildings. And now after those 3 weeks, we'll take a little break from that, and we'll look at some of the other more flexible functions within inside of this BIM modeling environment. We'll look at constructing a space frame with supporting what are called adaptive columns and some contextual structures around it. And this will give us, I guess, just a little bit of break, another way to look at how we can do architectural design, especially with creating freeform surfaces. Then we'll come back to our original model, and for you that are taking interior design or focusing on interior design, this should be a really fun or more interesting component of this course. We're going to custom build furniture, like the tables are custom built here. We're going to put monitors on the walls. We're going to create what are called ceiling clouds and add lighting systems to them. We're going to create a little office divider partition system. We're going to build custom monitors. We're going to work with lighting and rendering so that we can create photorealistic visualizations of our projects. We'll also put bathrooms in. We'll get the start of an idea about the spaces that are needed to meet code approvals with certain elements. This is a new one from last year. This is actually this green one here. This was the original way I was dealing with this idea of traditional elements. I was a little bit unhappy with this project, and I saw another one that was done by a local architect. So I thought this had a lot nicer features to it. So we're going to look at the idea of traditional details. We're going to put, we're going to add some, we're going to make a townhouse structure that has some traditional features to it, the bump outs, the trims, the moldings. We're going to have patios with exterior stairways. So we get a chance to look at more traditional kinds of architectural concepts. And we're going to then present that with different kinds of rendering styles. So this should give you a nice chance to move outside of the building and create very photorealistic looking or almost photorealistic looking renderings of our properties. Section 9, M9, is to prepare us for what will be other courses in the sequence, construction tech. And we look at now using the BIM modeler to detail our wall sections. So we'll build up custom wall units, custom wall elements with insulation and drywall on them. and we'll compare what it is to cut through the model just visually, and then what it is to make what is called a technical document of that. So this prepares you for the kind of work that you're going to really explore in detail in construction tech. This moves into the idea of M10 of what are called curtain wall modules. Curtain walls are the exterior walls on high-rise buildings that aren't supported, don't support the building load. They just support themselves. They're hung from the floors. And we look at the tools that are available to us to make modular curtain wall elements and some of the embellishments that go along with that. So this is just an introduction to creating this idea of curtain walls. And then we'll take that in M11 and we'll add these curtain walls in with some other elements and mix it up to create kind of a, how can I say it? Just a more visually intense piece of architecture. And the idea here is not so much the architecture itself, it's just to get you comfortable with the ways that you can start to modulate the facade to create volumetric effects, the way you can intermingle different kinds of surfaces. This window boxing idea is a relatively popular technique nowadays. So it helps you to bring this together as kind of a massing experiment at the same time where you're learning how to use these facade elements. And then we'll take two of those, we'll put them together, and we'll put them on a site somewhere on the campus. And we'll start to look at topography, generating roads, creating outdoor, some additional outdoor parking lots, access to the site. So this will prepare you to, when you get to studio work, to have a sensitivity to how you work the BIM modelers to create site and site context. And this is one of the more advanced, kind of towards the end of the course, advanced modeling techniques. We're going to use what's called node-based parametric programming to actually generate forms for us based on math. So in this case, we draw what's called an attractor line. And then we use that attractor line to generate the links of the ceiling panels. And this is kind of an advance on a project that I had done, and this is the early part of this project for a few years, and this is like the newer version of it. And I thought it was a much more compelling and interesting project to do. So this gets you involved with the idea of using math to create form, and the idea of using the tool called visual programming, node-based visual programming, where you're connecting a point to a line to something else and continue to add elements until we're building up an actual architectural representation. I also have what I call E-series, things that help you prepare for other things that you're going to want to do in studio work. One is about a form study where you actually can cut through and create a massing model and then apply all the kinds of building elements on it. Gives you an idea of how to work that within the BIM modeling environment. How to modify a shipping container in case you have a shipping container project. This one I think is fun and very informative. The idea here is that we look at an exterior patio with respect to sun. So we simulate daylighting on this, and then we add features to create shading and more comfortable exterior seating areas. And one that I think is really important, the idea of doing traditional brick-type facades, heavy masonry facades, creating the right kinds of reveals and edges where the setbacks of windows and surfaces articulate the kind of massing of traditional architecture. So these are available. I will try to do some of these as in-class active learning, but they're always going to be available to you on Blackboard. And that really kind of completes our introduction, our first lecture on this. So your first challenge, make sure that you have AutoCAD set up, or excuse me, AutoCAD or Autodesk's Revit set up. If you have any problems, email me. And otherwise, if you we're finishing at about 50 minutes. So what we can do is spend this time starting on our lab component to get a head start on that.